So, today we are going to start covering. This is one of my favorite topics: special types of right triangles. So, we're going to start with one of the simpler one I believe to work with, which is this isosceles right triangle. If we can recall, an isosceles triangle is a triangle where two sides of the triangle have the same length. Now, this is a right triangle. We can tell just by looking, it has a right angle. And it's isosceles. Now, the interesting thing about an isosceles triangle is that the two base, you would call them base angles or whatever, these two angles are the same length. So these have the same measure. Now, if that's true, then we can find out what those measures are fairly easily, using the fact that all three angles of a triangle add up to 180 degrees. So if I called this like angle 1 and this is angle 2, then I would have that 180 is equal to 90 degrees because it's a right triangle, plus the measure of angle 1 plus the measure of angle 2. Now, subtracting 90 degrees on both sides, we would get that, of course, 180 minus 90 is 90. And that's equal to the measure of angle 1 plus the measure of angle 2. But both of those measures are the same. We know that since the triangle is isosceles, the measure of angle 1 is equal to the measure of angle 2. Now, if that's true, then we only have like one possibility what the measure of angle 1 and angle 2 are. What number added with itself gets 90? Well, that means that angle 1 and angle 2 would both have to be 45 degrees, because 45 plus 45 equals 90. So we can determine precisely what the measures of these two angles are in any isosceles right triangle. These two angles are always 45 degrees. So that's an interesting property. But what else is there to learn about this kind of triangle? Well, the other important theorem we learned about with right triangles was the Pythagorean Theorem. Now, the Pythagorean Theorem is a way in which we can sort of find typically we would have two side lengths and we could find a third missing side length in a right triangle using it. But what if I don't know anything about this triangle in terms of like the values of its sides? What if I just knew that it was isosceles and it was a right triangle? Well, because it's isosceles, I know that, xy has the same length as yz in this case. So if we use like Pythagorean theorem, I guess I could call this like side, like if normally it's A, B, and C is the hypotenuse. But in this case, A and B have the same lengths. So I can just use the same variable A, and C is still my hypotenuse. And let's use the Pythagorean theorem and see if we can determine any interesting things about the length of C. So, Pythagorean theorem is each leg squared when added together equals the hypotenuse squared. So I have A squared plus A squared is equal to C squared. And A squared plus A squared, well, they're like terms. We can combine them. A squared plus A squared is 2A squared. And that's equal to C squared. And from there, if I wanted to solve for the hypotenuse, C, we would take the square root on both sides. So take the square root there and the square root there. Now the square root of c squared is just c. And when I take the square root of 2a squared, what that means I can really do is you can sort of separate this out as the square root of 2 times the square root of a squared. And going down a little bit, the square root of a squared, well, the square root is like the inverse operation of squaring something. So the things would cancel each other out. So you get the square root of 2 times just a. But more commonly, we write this out as a times the square root of 2. So that's interesting. So we found out that we can write c in terms of the value of a, where the hypotenuse is actually just the length of a times the square root of 2. And this is a important property, so important that it is like just super crucial when going on to things like trigonometry. And this is sort of something we study on its own. We call this the 45-45, this should say like 90 right triangle, where each leg has a length of a, and the hypotenuse has a length of a times the square root of 2. So just like we discovered. And as we will see in a couple, in the next video, when we go through some problems, that it's really quite easy to work with. And, you know, like in any 45-45-90 triangle, you know it's isosceles since the two angles are the same. The two angles are the same. That means the sides are the same in a triangle. And I will show you how easy it is to work with triangles knowing the facts that we have established so far.